Hi, I'm Stuart McErlain-Naylor from the University of Suffolk, and this will be a quick presentation on our research into the effects of three different delivery types on upper body kinematics during cricket batting. So I'll jump straight into a bit of background literature review, and through our recent research into power hitting kinematics, we've developed a bit of a deterministic model, but for relevance to today's presentation, I'll focus on the bottom right corner of this, really. So looking at what factors contribute to bat speed. We've found three key kinematic factors, and their order of importance follows a kinetic chain from proximal to distal. So the single most important factor has been X factor, which is the separation between pelvis and thorax. The second most important, slightly more distal, is the magnitude of lead elbow extension during the downswing. And the third most important and more distal still is the magnitude of wrist uncocking during the downswing. Shine a bit more light on that. Firstly, what is X factor? Well, I've drawn a red line here through the pelvis and a blue line through the thorax segment. And we see that prior to ball release, when these are mapped onto the ground, there's very little separation. However, during the backswing, these lines start to separate as the pelvis and thorax separate, and they then recoil during the downswing. And it's the magnitude of this separation, or the size of the X, which has been linked to performance in cricket batting, as well as other sports, such as golf or baseball. And the second principle I mentioned is the kinetic chain, which is simply referring to the transfer of momentum from each segment into the adjacent segment. So again, from proximal to distal. And hopefully, if the movement is coordinated well, we'll see an increase in distal endpoint velocity at each subsequent segment down the chain. And to highlight this, I've got an example from our recent badminton jump smash research. I've coloured each segment on the dominant side from white being zero velocity through to red being that segment's maximal velocity. And we can see the kinetic chain going down the body during the initial jump and then back up the body during the smash, so that the racket head speed is at its highest at contact with the shuttlecock. And finally, some research from Muller and Abernethy looking at the effect of visual occlusion on performance in batting. Both highly skilled and lesser skilled players were able to contact the ball when there was no visual occlusion, but also when vision was occluded prior to the ball bouncing. And this tells us that both sets of players are able to use information available before the ball bounces in order to inform their shot selection. However, when vision is occluded before the ball is even released, we see that highly skilled players are still able to contact the ball some of the time. And this tells us that they are able to use information before the ball is released to inform their shot selection and their subsequent execution of their movement solution. So, for example, this could be information from the run-up of the bowler or the bowler's kinematics prior to them releasing the ball. And this raises some questions about how appropriate it is to train using a bowling machine, where the benefit is the lack of training load on bowlers, especially fast bowlers who are already at an increased injury risk. But the negative may be the lack of pre-release visual information. A compromise may be the sidearm thrower, where we can see in this video both coaches in the background using the sidearm so that we're not having to overwork the bowlers, but there's still some visual pre-release cues available for the batsman to work with and learn to take in. So the aim of our study then was to determine the effect of these three different delivery methods on upper body kinematics in both a front foot and a back foot cricket shot. We recruited 14 batsmen and a wide range of abilities and recorded a number of successful trials against each delivery type. So around 10 on average against a bowling machine, and then due to an increased variability in delivery, slightly less against a sidearm from an experienced coach, and also against an elite university fast bowler. For each successful trial, we recorded technique at 4 key instants of ball release, start of backswing and downswing, and impact. We looked at the timings of those 4 relative to one another, and we also looked at a total of 25 upper body kinematic parameters split over those 4 key instants. We firstly compared these for the front foot drive, and we found that against the bowling machine, when there's the least pre-release visual information available, players exhibited the least extension and adduction at the back shoulder. So to simplify that, when there was less visual information available, they had a smaller backswing at the shoulder, with no differences seen during the downswing or at impact. So we concluded that delivery type or the visual cues available do not affect at least upper body kinematics during the drive, other than the magnitude of back shoulder extension and adduction. For the pull shots, we found that the backswing was initiated earliest against the bowler, which makes sense when we think that there's the most visual information available in this condition. But to compromise, in the sidearm, and then even more so in the bowling machine, when there's less information available, because the backswing will start later, players were taking up a starting position where the bat was already pulled back slightly. We then found that the X factor, at least in the frontal plane, was greatest in the bowler, then the sidearm, then the bowling machine, again in the conditions where they're able to initiate the movement earlier. We saw more back elbow extension in the kind of intermediate sidearm condition, and then more wrist uncocking in the bowling machine condition. So going back to this diagram from earlier, we can say that we had the greatest X factor in the bowler condition when there's the most visual information available, more back elbow extension in this case in the sidearm condition, and more wrist uncocking in the bowling machine condition. So the movement becomes more distally dominant the less visual information is available prior to ball release. And this led us to conclude that delivery method or visual cues do affect upper body kinematics during the pull shot. The sidearm might be a compromise between the other two, but we should be aware of differences in proximal to distal joint dominance and should try to ensure that batsmen are exposed to that pre-release visual information as much as possible. If you're interested in finding out more, please do go and read the full abstract, which should be available on ResearchGate as well as in the ISBS archive. The other references are there. And thank you very much for your time.